Okay, let's answer questions on your last assignment, 10-4. All we were doing, for those of you who weren't here, who wasn't here? Kate and Trey and anybody else? Okay, Kate and Trey, you guys weren't here. We learned area formulas, Kate. How to find the area of a triangle, how to find an area of a parallelogram, and how to find an area of a trapezoid, okay? She's awake. All right, so that's what we did last time. Area of triangles, trapezoids, and parallelograms. That's what we did last time. So we just reviewed the formulas for those. So are there any questions on the homework assignment from last time before we correct it? Huh? 14. Okay. Hey, Trey, if you want to get that out and be working on it, you could make a big dent in it. Huh? Well, ask somebody that was here. 10-4. Okay. Number 14, did you say? All right. 14 is a triangle that looks like kind of like that, right? And we extend this side out right here to drop down the altitude, which is going to be our height, which they tell us is 15 1/3 centimeters. We're also given that the base, you guys, my eyes are getting bad. Does that say 18 centimeters on number 4? Yeah. The base? I can tell that's not a 2. Okay, so we get that. And we have to find the area of this triangle. Okay, well, what does our formula tell us, Jordan? What's the area formula for a triangle? What's the area formula for a rectangle? Trey. What's the area formula for a base times height? Remember, a triangle is half of a parallelogram or a rectangle, so all we do is divide it by 2. That's how you remember it. You just remember that a rectangle or a parallelogram is base times height. And all you have to do is a triangle is half of that, so you divide it by 2. So what's the base and what's the height on this problem? Okay. So 18 times 15 1/3, right? All divided by 2. I can divide 2 into 18. That's 9. So it's just 19 times 15 1/3. 9 times 15 1/3, sorry. Okay, so, well, I know that 15 9 times is going to be like 135. It's going to be 138, I believe. Is that right? If I do this in my head. Is that right? 138 square centimeters is the answer to that problem. What? Because some of you guys probably use your calculator and change 1/3 to a decimal, right? And what happens when you change it to a decimal like that, you're going to lose a little bit because you're rounding it, and so you don't have the full number. Yeah, I'll give it to you. You guys know the method, but you got to realize 1/3 is 0.3 repeating, and you probably put, I'm guessing by how far you were off, Johnny, I'm guessing all you put is 0.3 in your calculator. And it should have been 0.33333. Okay. So, well, you want to just put as more threes you put in, the closer your answer is going to be. 0.3333333. Okay. All right. Any other questions? Taylor. Number 20. Okay, number 20. Find the area of a trapezoid whose altitude measures 4 inches and whose bases are 5 1/3 inches and 9 inches. Well, number 20, if it was me doing that, I would draw a picture of a trapezoid. Okay? And then I'd put them in. It says the altitude is 4 inches. What is the altitude? What does that mean? It means the height. It means the perpendicular distance from there to there. I can draw it over here. I can draw it right here. I can draw it in the middle like this. Okay? That is 4, what was it? Inches? Okay. And the bases are 5 1/3 inches and 9 inches. Which one do you think is 9? Why? Okay, because it's longer. 9 inches and 5 1/3 inches. What's the area formula for a trapezoid? 1/2 times the height. What's the height? 4 times the two bases added together. 9 plus 5 is 14 and 1/3, so 14 1/3. Right? And then I can just divide 2 into 4 and get 2. And 2 14s make 28, and 2 1/3s make 2/3. So I know this is going to be 28 and 2/3 square inches. Does that answer your question for you? Okay, you can be working on these. Don't just write down the answer. Show me the work. You guys, show me the work on these. I expect to see some work. Write down what you put into your calculator. Okay. Then write it down on the paper. Anyway. Okay. Just do it, Trey. Okay. Any other questions? Okay. Huh? Ready to correct it? Okay, everybody. Pass your paper to the person. Bye. All right. So what is the perimeter of this? Well, I mean, what is the area of this? We're going to break it down into 6 triangles. If it's a regular pentagon, what would I break it down into? 5 triangles. If it was a decagon, how many sides does a decagon have? 10. So I'm going to break it down into 10 triangles, right? If it's a heptagon, which is a 7-side, you'd break them down to 7 triangles. You can't do it by drawing the diagonals in. What you do is you put a point right in the center, and you draw it to each vertex. So if I had a heptagon, I would just, regular heptagon, I'd put a point, find the center, and I would draw a triangle to each one, okay? So in order to do this, you guys, we're going to need to know a couple things, because on a triangle, you need to know the base and the height, right? And those are the 2 things I'm going to teach you right now. The base consists of this, but we're going to, instead of, the formula consists of finding the base of all of them and adding them together, which is called the perimeter, right? Yes.
Wouldn't it be just like the base times the one to the line to the middle times by 6?
Yep, that's it. Okay, times the base. Yes, this is going to be very easy. Let me show you right here. You guys, first of all, let's find the perimeter of this thing. What's the perimeter of this triangle? Okay, 6 times 8 is 48, right? Okay, it's 48. So you're going to times that's the perimeter, and that's the length of all the bases, right? And then we call this line right here, I've written it right down here, it's called the apothem. Some people call it apothem. I don't know if it's apothem or apothem. It's one of those. Okay, apothem. I think it might be apothem, but I call it apothem. Okay, so on the apothem right here, you have this point from the center, perpendicular to the side. Notice it's not one of my. It doesn't go from the center to the vertex. It goes from the center and is perpendicular to one of the sides because it has to be the altitude, right?
Yeah.
See, and if I was doing this triangle right here, if I was finding the area of this triangle, let's say that this was 6 inside, or let's say it's 5. I would go 1/2 times the base times the height, right? But since there's 6 of those triangles, I would times it by 6, right? Well, when we did 6 times 8 down here and got 48 for the perimeter, that's why we wrote it that way. And we're going to write this formula as area equals 1/2 times the perimeter times the apothem. And that right there, you guys, is the area formula for a regular polygon. You could cut it off into 2 trapezoids, but we're trying to find one that will work for every kind of polygon. If I did that, you're right. You're exactly right. It would be a longer. You'd have to find the area of 2 trapezoids. Okay? So let's go to this one right here. How do you think you can find the area of a regular pentagon based on what we have learned in the past? Well, okay, who wasn't mentioning to me, what if it's an odd number of sides? Okay, Trey. See, Trey, sometimes he asked a legitimate question. Look at, all I would do is put a point in the middle, Trey, and then I would have to draw a line to each side. I couldn't just draw those diagonals in. And in theory, if I could draw, we would have 5 congruent triangles, right? Yeah. So if I know where the center is and I can measure the apothem right here, if I can measure the apothem, I would have 1/2 times the perimeter times the apothem, okay? And that would give me the formula for that. That's what you guys need to know. 1/2 the perimeter times the apothem. Huh? Apothym. Whatever apo means. Okay. All right, here we go. We're going to do a couple examples. Let's say I knew this right here. Let's say I knew this distance right here was 7 centimeters. And let's say the length of one of the sides, let's say this side up here, was 10 centimeters. I want you guys to find the area of that hexagon. Find the area of that hexagon. When you got it, what do you got, Mitchell? I didn't get that, and I did it in my head. That's what I got in my head. You guys, you should have got 210. Is that how many of you got 210? Okay. Because what you would have done is 1/2 the perimeter. The perimeter is one of the sides times 6, right? Because there's 6 sides. So 6 times 10 is the perimeter, times the apothem, which is 7. I know that 1/2 of 6 is 3, and 3 times 10 is 30, and 30 times 7 is 210 square centimeters. Okay? Got that? On your end of level test, there's always one problem where you have to find the area of a regular polygon. Okay? Well, there's only like there's 70 questions usually on the test, and there's usually only one. I could be wrong. There could be more than that. I know I usually see one at least. Okay? Let's say this time I know that this length is 12 inches. I know that this length right here is 8 inches. And I know that this right here is 10 inches. Find the area of that polygon.
Come on, people. You got this. Most of the first. Drop that. Just look at the rest.
Okay. Raise your hand when you think you got it. I got a number in my head. I don't know if I did it right. We'll see. Okay. Johnny, what did you get? You got what? 200? What'd you guys get? That's what I got. 200. Okay. So on this one, you guys, I tried to throw you off. What did I try to throw you off with? I gave you this distance right here. Is this the apothem? Nope. So if you use this number right here, you got it wrong. You had to use the one that was perpendicular to one of the sides, right? So 1/2 the the perimeter, which is 10 times 5, which is 50, right? Times the apothem, which is 8.
You could actually figure it out. Just times other, right?
No, I mean, well, if you knew this, if you knew if you didn't know how long this was and you knew how long this was, you know that would be 5, and you can use the Pythagorean theorem to figure out that length right there, yeah. But it'll be different than 8 inches because I just made up some numbers.
No, I know.
Yeah, you could. Okay, you could do it. All right, you guys ready for the homework assignment for this one? Okay, here we go.
Split it up into 5 squares.
Yeah, a lot of them can be split up in different lengths like that.
Just not head over.
Okay, here we go. Lesson 10-5. Page 429. I am going to have you guys do (7) through 13, 18, and 22. Now, I got to mention one other thing about this lesson, looking at the problems on there. They take out some shaded regions in here, so I'm going to talk about that.
Well, oh. Just have to find the area of the shaded area of the ball.
Yep. Hey, you guys, everybody turn your book to page 10-5. I want to mention a few things, but you got to look at the pictures. Look at problem number 10. You're supposed to find the shade of the area, the shaded area of that hexagon, right? And Mitchell was just saying, couldn't we just find the area of the whole thing and subtract the area of that triangle? So you're gonna this is 3 problems in one. You ready? You got to find the area of the regular polygon, then find the area of the triangle and subtract the area of the triangle from the polygon, and you'll have the shaded area. Got it? Look at number 11. What are you going to find the area of first? Okay, you can find the area of the square, and then what else? Then the pentagon, and then do what? Subtract the square from the pentagon, right? Subtract the square from the pentagon. Because the pentagon area is going to be bigger, because the square is inside the pentagon. Okay. Number 12. What 2 shapes are those? No, it's a hexagon. It's 6-sided. Hexagon and a trapezoid. So you find the area of the hexagon, find the area of the trapezoid, subtract the area of the trapezoid. Does that make sense? Can you do that? Okay. All right. For those at home, we just did 10-5, symmetry. There wasn't much to show, so I didn't turn it on, but here's the assignment. Lesson 10-5, page 437. We're going to do 13 through 26 all and 30 through 35 all. What? Yeah, that's what I meant. 10-6, sorry. We just did 10-5, right? Okay, 10-6. You guys should be able to whiz through that one because all it is saying symmetry and a couple of review problems at the end. Okay, that is your assignment on line symmetry and rotational symmetry. Okay, next time we come to class, guess what we're going to do? We are going to take a test. We're going to take a test. Chapter 10 test. Are we cruising or what? Okay, we're going to take the chapter 10 test. What was that? The last test? Yeah, it wasn't too long ago. No, because we did 10-2, 3, and 4, and then 5 and 6. So it's been about 6 days since we did it. Okay, so test. We'll review before we take the test. We'll take the test towards the end of class, okay? Everybody got that?